The following is a brief introduction to vaporizing foil actuator welding, or VFAW, which is a specialty of the Impulse Manufacturing Laboratory at The Ohio State University. VFAW is a type of collision welding, which is a technique for joining metals by means of a high-speed oblique collision. Such a collision removes the surface oxide layers from both metals and brings fresh metals into intimate contact, thereby producing a metallurgical bond. This technique involves no heat input and no melting, so it is a type of solid-state welding. Traditionally, the necessary high speed is achieved by explosives, and this is called explosion welding. Collision welding has been shown to be capable of joining a wide range of dissimilar metal pairs which cannot be easily welded by other means. A collision welded joint is often characterized by a wavy interface due to the turbulent plastic flow which takes place during the welding process. Vaporizing foil actuator welding, unlike explosion welding, is on a much smaller scale and does not involve explosives. Instead, it uses a piece of aluminum foil which is cut into a dog bone shape and connected to the output end of a capacitor bank. When the capacitor bank is discharged, the foil is electrically vaporized within tens of microseconds, and the expanding gas from this rapid vaporization provides the driving force to propel a thin sheet of metal into a high-speed collision with a target plate. The peak velocity of the flyer plate is typically on the scale of hundreds of meters per second. Thus, this technique is able to achieve explosive-like speeds without using explosives. The setup of VFAW involves very light tooling. We start with a block of steel. The vaporizing foil actuator is laid on top, and then the flyer, which is the metal sheet to be propelled, is laid on top of the vaporizing foil actuator with electrical insulation in between. Plastic standoff sheets were then put in place. The target plate, which is the stationary piece of the colliding tandem, is placed on top, a standoff distance away from the flyer. Finally, everything is constrained by another heavy block of steel and bolted down. Below is a side view of the welding process. The rapid vaporization of the foil propels the flyer toward the target into a high-speed collision, resulting in a welded joint. A material joint made by VFAW exhibits the wavy interface which is characteristic of collision welding. It is similar to that which is observed in an explosion welded joint, but on a much smaller scale. The joints exhibited fair strength, as revealed by peel testing, and material analysis of the fracture surface shows material transfer across the interface, proving that the joint failed in the parent materials and not just along the interface. In summary, vaporizing foil actuator welding serves as an agile way to carry out collision welding on a laboratory scale with fairly light tooling. Features comparable to those found in explosion welding are achieved without using explosives. I'm on my way to the Impulse Metalworking Lab. This is it.
So we are trying to weld stainless steel with aluminum here, a 3 or 4 grade stainless steel to be welded with 6061 aluminum in a T4 temper condition. And here's our VFAW setup. You can connect it to the terminals of the capacitor bank, which we have over here. This capacitor bank can charge up to 16 kilojoules, but we are going to not use all of that. We're probably going to use 8 kilojoules of that. So while the flyer is accelerating, we are also going to measure the velocity of that by looking at the flyer through this hole which has been drilled into the VFAW setup through a PDV probe.
What Alex is doing right now is aligning the laser. When he aligns the laser properly, there will be a visible fluctuation on the trace, on the oscilloscope. And there's the fluctuation.
So during the experiments, we also run some diagnostics. We measure the current by using a Rogowski coil, the voltage by using a 1000 to 1 voltage divider, and the velocity of the flyer by using a laser-based system called the photonic Doppler velocimeter. Here's our capacitor bank, which has a total energy of 16 kilojoules. Out of that, we are only going to use 50%, which turns out to be 8 kilojoules, or in other words, it's 80 100-watt light bulbs lit up for 1 second. Fire in the hole!
So we took the whole assembly out of the boombox, and we're about to open it up and examine our product. Good.
So you can see the foil is completely vaporized, and what is left behind is this aluminum and stainless steel weld.
Beautiful.
The professional wiggle test?
Yep, it's stuck together, folks. It's real.